This video is for my Math 161 students working on the assignment graphing log functions. So number one, we're asked to identify the domain of this log function. So to find the domain, remember the formula is the rule is to set the log argument. The log argument has to be greater than 0. You cannot have a negative log argument. So if you want to find the domain of a log function, just grab that log argument and set that greater than 0. Now let's add 3 to both sides. Then I will get x is greater than positive 3. So if you write that as your answer, that's good. If you want to write this in interval notation, then you can try to maybe imagine a picture of it. Let's say you're going to have our 3 over here with an open circle because there's no bar underneath this inequality. And when they say x is bigger than 3, we're going to the right side. So if you keep on going to the right side, the interval notation will start from 3, but it will go to positive infinity. So let me highlight the answers here for you. X is greater than 3 or 3 comma infinity are both acceptable forms of answers for number 1. So these are the domain of this log function. Okay. Now let's do number 2. Number 2 is asking us to identify any intercepts of f of x. So let me do the, which intercept first? I'll do both. So there are x-intercepts and let me draw a line here. I'm going to find a y-intercept. I'll do the y-intercept first because that's usually the easier one. If you want to find the y-intercept, you're going to plug in x equals d0. Okay, plug in x equals 0 because to be on the y-axis, to be on this y-axis, you see that horizontal axis, you're not allowed to go to the right or left. So the x value cannot be 1, 2, 3 or negative 1, 2, 3. You see, to be on the y-axis, the x value has to be 0 because it has to be on this line. So that's why we're plugging in x equals 0 to find the y-intercept. So let's see what that is. Y equals natural log of 0 minus 3. Uh-oh. Now let's look at this. This is natural log of negative 3. Now, can I have a negative log argument? This is not real. This is not defined. Well, because remember, we just said for part A that domain, the possible x values are numbers that are bigger than 3, right? So x equals 0. 0 is not bigger than 3. 0 is smaller than 3, right? So that's why this function, all right, I'm going to go ahead and write the answer. What's wrong with my D? Let me try to fix this. F has no y-intercept, or we can just say none for y-intercept. Okay, I'm going to now go over here and find the x-intercept. Okay, hold on, it's a little longer. Okay, so if I want to find the x-intercept, I set the whole function equal to 0. So it's the same as plug in y equals 0. Do you see the similarity in the method? If I wanted the x, if I wanted the y, then I plug in x equals 0. If I want x-intercept, then I plug in y equals 0. Okay, so let me see. The equation was y equals natural log of x minus 3, right? I'm going to plug in 0 into y. So that will give me 0 equals natural log of x minus 3. Now let's solve this by rewriting this in exponential form, okay? ln, natural log, is base e. Remember that? If it says natural log, this is base e logarithm. So what I can write is this is the same as e to the 0 power equals the log argument of x minus 3, okay? So what I did in this dark green pen is rewriting this equation in exponential form, okay, with base e, exponent 0, and the log argument of x minus 3 on the other side. Now let's evaluate this, okay, let's solve this. Anything to the 0 power is 1. So x minus 3 is 1. So if I add 3 to both sides, we'll get x to be positive 4. So this is, it says 4 equals x, but I want to write it as x equals 4 is the x-intercept of this graph, okay? So, all right, let's see. Question 3 is asking us to identify any asymptotes of f, okay? Now remember, I think I'm going to try to copy this down. Down here, okay? And I will also get the equation too. The default log function have a vertical asymptote at x equals 0, okay? But take a look at this one. We have natural log of x minus 3. So this subtracting 3 will move the graph. This will shift the graph 3 unit to the 3 to right. This will shift the graph 3 to the right. So 3 to the right. To the right. So the default, like any log function, like let's say I'm gonna just make a y equals natural log of x, has a vertical asymptote at x equals 0. Okay, that's the default. But with this shift, you notice that we just shifted this graph 3 to the right. We're not going to have a vertical asymptote at 0 anymore. The graph got moved 3 to the right. So my answer is going to be f of x has a vertical asymptote at x equals what number? 3. Because it's been shifted 3 units to the right, its vertical asymptote shifted too. Okay? All right. Let me do the last one. I believe the last one is graphing. So this time we're sketching a graph of f of x. Okay? Copy this. Hold on. Sketch a graph. Oh, whoopsie daisies. I don't know that. Sketch a graph of f of x. So, you don't have to plot every single point, but do this for me. Have your x-axis and have your y-axis. Okay. Sketch that vertical asymptote of x equals 3. Okay, so you will go 3 to the right, 1, 2, 3, and use a dotted line to sketch a vertical asymptote at 3. So one point that I'm grading for is you graphing a vertical asymptote of this graph, okay? Now, what else? This graph has look at this point, an x-intercept at x equals 4. So you will plot a point at x equals 4 on the x-axis. So you go 4 to the right and then plot a point here. And that's really all I'm going to look for. And as long as your graph is decreasing as it get close to that vertical asymptote, never touching it, and increasing to the right. I don't think I'm going to ask you to plot another point here, but that's how you can graph this natural log function. Okay, so when you are done, scan and submit your work on Canvas for me, and I'll grade it using that grading rubric.